EMT, or electrical metallic tubing, fittings are a common component in electrical installations. However, their suitability for use in wet locations is a frequent point of discussion. It's important to understand the standards and regulations governing their application, specifically concerning UL, underwriters' laboratories approval and the National Electrical Code requirements. UL does not approve EMT fittings specifically designed and rated for wet locations. This means that there isn't a listed EMT fitting that carries a UL mark indicating its compliance with standards for use in continuously wet environments. The historical context reveals that UL may have, at some point, considered or even approved certain EMT fittings for wet locations, but that the approval was rescinded around 2001. This change in approval status is significant because it affects how these fittings can be used in electrical installations while remaining compliant with safety standards and codes. The National Electrical Code, a widely adopted standard for safe electrical installations, doesn't explicitly require the use of EMT fittings in wet locations. This absence of a mandate provides flexibility in selecting appropriate conduit types for outdoor or wet environments. However, the NEC does specify requirements for the type of raceway and fittings used based on the location and environmental conditions. When dealing with outdoor piping in wet locations, it's common practice to use alternative conduit systems. Two frequently used options are PVC conduit and metal conduit. PVC, or polyvinyl chloride, conduit is a non-metallic raceway that offers excellent resistance to moisture and corrosion. It is suitable for direct burial and exposure to weather, making it a popular choice for underground and outdoor applications. When using PVC conduit in wet locations, it's crucial to ensure that all fittings and connections are also rated for wet locations. This includes using proper PVC cement to create watertight seals at joints and connections. Metal conduit, on the other hand, provides a robust and durable raceway for electrical conductors. Options include galvanized rigid conduit, intermediate metal conduit, and aluminum conduit. Galvanized rigid conduit offers superior protection against physical damage and corrosion. It is often used in applications where the conduit is exposed to harsh environmental conditions. Intermediate metal conduit is a lighter weight alternative to galvanized rigid conduit, offering similar protection at a reduced cost. Aluminum conduit is lightweight and corrosion resistant, making it suitable for use in wet and corrosive environments. When using metal conduit in wet locations, it's essential to use fittings that are specifically designed and listed for wet locations. These fittings are typically made of corrosion-resistant materials such as stainless steel or coated steel and are designed to create watertight seals. The choice between PVC conduit and metal conduit depends on several factors including the specific environmental conditions, the level of physical protection required, and the budget. In situations where corrosion is a major concern, PVC conduit may be the preferred choice. However, in applications where physical protection is paramount, metal conduit may be more suitable. When installing any type of conduit in wet locations, it's critical to follow the manufacturer's instructions and all applicable codes and standards. This includes properly supporting the conduit, using appropriate fittings and connectors, and ensuring that all connections are watertight. Failing to follow these guidelines can result in electrical hazards, equipment damage, and code violations. In summary, while EMT fittings are not approved for wet locations by UL, the NEC does not require their use in these environments. PVC and metal conduit are commonly used alternatives for outdoor piping in wet locations. When selecting a conduit system for wet locations, it's important to consider the specific environmental conditions, the level of physical protection required, and the applicable codes and standards. Always use fittings and connectors that are specifically designed and listed for wet locations to ensure a safe and reliable electrical installation. This information is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before undertaking any electrical work. Understanding the nuances of conduit selection and installation in wet locations is essential for ensuring the safety and longevity of electrical systems. Here's a more in-depth look at some key considerations. Firstly, material selection. The choice between PVC and various types of metal conduit depends significantly on the specific environmental conditions and the project's budget. PVC is generally more cost-effective and highly resistant to corrosion, making it ideal for applications where exposure to moisture, chemicals, or salt is prevalent. Metal conduits, such as galvanized steel, stainless steel, or aluminum, offer superior mechanical protection and can withstand higher temperatures. However, they may require additional protective coatings to prevent corrosion in harsh environments. Secondly, fitting selection. Regardless of the conduit material chosen, the selection of appropriate fittings is critical for ensuring a watertight and secure electrical system. Fittings for wet locations are designed with features like O-rings, gaskets, and watertight seals to prevent moisture ingress. These fittings must be listed for wet locations, indicating that they have been tested and certified to meet specific performance standards. It's important to ensure that the fittings are compatible with the chosen conduit material and that they are installed according to the manufacturer's instructions. Thirdly, installation practices. Proper installation techniques are essential for maintaining the integrity of the conduit system and preventing water from entering the electrical system. This includes ensuring that all conduit joints and connections are properly sealed and that the conduit is adequately supported to prevent sagging or movement. When installing conduit in underground applications, it's important to follow the NEC guidelines for burial depth and to protect the conduit from physical damage. Fourthly, code compliance. Adherence to the National Electrical Code is paramount for ensuring the safety and compliance of electrical installations. The NEC provides specific requirements for the selection and installation of conduit systems in various locations, including wet locations. It's important to be familiar with the relevant NEC articles and to consult with a qualified electrical inspector to ensure that the installation meets all applicable code requirements. Fifthly, grounding and bonding. When using metal conduit in wet locations, proper grounding and bonding are essential for preventing electrical shock hazards. The metal conduit must be effectively grounded to provide a low impedance path for fault currents to return to the source. Bonding jumpers should be used to ensure electrical continuity between all metal components of the conduit system. It's important to follow the NEC guidelines for grounding and bonding to ensure a safe and reliable electrical system. Sixthly, expansion and contraction. In outdoor applications, conduit systems are subject to expansion and contraction due to temperature variations. This can cause stress on the conduit and fittings, potentially leading to leaks or damage. To accommodate expansion and contraction, expansion fittings should be installed at appropriate intervals. These fittings allow the conduit to move without putting stress on the system. Seventhly, drainage. In some applications, it may be necessary to provide drainage for the conduit system to prevent water from accumulating inside the conduit. This can be accomplished by installing drain fittings at low points in the conduit run. Drain fittings allow water to escape while preventing debris from entering the conduit. Eighthly, inspection and maintenance. Regular inspection and maintenance of conduit systems in wet locations are essential for identifying and addressing potential problems before they become serious. This includes checking for signs of corrosion, leaks, or damage to the conduit or fittings. Any problems should be promptly repaired to maintain the integrity of the electrical system. Ninthly, documentation. Maintaining accurate documentation of the conduit system, including the materials used, the installation methods, and any modifications made over time, can be helpful for future maintenance and troubleshooting. This documentation should be kept in a safe and accessible location. Lastly, professional consultation. When in doubt, it's always best to consult with a qualified electrician or electrical engineer. These professionals have the knowledge and experience to design and install conduit systems that meet the specific requirements of the application and comply with all applicable codes and standards. By carefully considering these factors, it's possible to design and install a safe, reliable, and code-compliant conduit system for wet locations. Remember to always prioritize safety and to consult with qualified professionals when necessary. Choosing the right type of conduit and fittings for wet locations requires a careful evaluation of the environment and the specific requirements of the electrical system. Here is a breakdown of the key considerations to help make an informed decision. Firstly, understand the environment. The first step is to thoroughly assess the environmental conditions in which the conduit will be installed. This includes considering factors such as the level of moisture, the presence of chemicals, the temperature range, and the potential for physical damage. For example, in coastal areas where exposure to saltwater is high, corrosion-resistant materials like PVC or stainless steel are essential. Secondly, consider the NEC requirements. The National Electrical Code provides specific guidelines for the selection and installation of conduit systems in various locations, including wet locations. It's important to be familiar with the relevant NEC articles, such as Article 300, Wiring Methods, and Article 344, Rigid Metal Conduit RMC, to ensure that the installation meets all applicable code requirements. The NEC defines a wet location as an area subject to saturation with water or other liquids such as car washes, laundries, and locations exposed to weather. Thirdly, evaluate conduit material options. PVC conduit is a popular choice for wet locations due to its excellent resistance to moisture and corrosion. It is also lightweight and easy to install. However, PVC conduit may not be suitable for applications where high temperatures or physical damage are a concern. Rigid metal conduit (RNC), galvanized steel conduit offers superior mechanical protection and can withstand higher temperatures than PVC. However, it is heavier and more difficult to install. RNC must be properly grounded to prevent electrical shock hazards. Intermediate metal conduit (IMC) is a lighter-weight alternative to RMC, offering similar protection at a reduced cost. IMC is also easier to install than RMC. Aluminum conduit is lightweight and corrosion-resistant, making it a good choice for wet locations where weight is a concern. However, aluminum conduit is more expensive than steel conduit. Electrical metallic tubing (EMT) is a thin-walled conduit that is easy to bend and install. However, EMT is not approved for use in wet locations unless it is specifically listed for that purpose. Flexible metal conduit (FMC) is a flexible conduit that is used for short runs and connections to equipment. FMC is not watertight and should not be used in wet locations unless it is installed with watertight fittings. The Conduit flexible metal conduit (LFMC) is a flexible conduit that is covered with a watertight jacket. LFMC is approved for use in wet locations when installed with listed fittings. Fourthly, select appropriate fittings. The selection of appropriate fittings is just as important as the selection of conduit material. Fittings for wet locations must be listed for that purpose and must be compatible with the chosen conduit material. Wet location fittings typically have features such as O-rings, gaskets, and watertight seals to prevent moisture ingress. Fifthly, ensure proper installation. Proper installation techniques are essential for maintaining the integrity of the conduit system and preventing water from entering the electrical system. This includes ensuring that all conduit joints and connections are properly sealed and that the conduit is adequately supported to prevent sagging or movement. When installing conduit in underground applications, it's important to follow the NEC guidelines for burial depth and to protect the conduit from physical damage. Sixthly, consider grounding and bonding. When using metal conduit in wet locations, proper grounding and bonding are essential for preventing electrical shock hazards. The metal conduit must be effectively grounded to provide a low impedance path for fault currents to return to the source. Bonding jumpers should be used to ensure electrical continuity between all metal components of the conduit system. Seventhly, plan for expansion and contraction. In outdoor applications, conduit systems are subject to expansion and contraction due to temperature variations. This can cause stress on the conduit and fittings, potentially leading to leaks or damage. To accommodate expansion and contraction, expansion fittings should be installed at appropriate intervals. Eighthly, provide drainage. In some applications, it may be necessary to provide drainage for the conduit system to prevent water from accumulating inside the conduit. This can be accomplished by installing drain fittings at low points in the conduit run. Ninthly, inspect and maintain regularly. Regular inspection and maintenance of conduit systems in wet locations are essential for identifying and addressing potential problems before they become serious. This includes checking for signs of corrosion, leaks, or damage to the conduit or fittings. Lastly, consult with professionals. When in doubt, it's always best to consult with a qualified electrician or electrical engineer. These professionals have the knowledge and experience to design and install conduit systems that meet the specific requirements of the application and comply with all applicable codes and standards. By carefully considering these factors, it's possible to select and install a conduit system that will provide reliable and safe electrical service in wet locations. Remember to always prioritize safety and to consult with qualified professionals when necessary. Let's delve deeper into specific aspects. Firstly, specific NEC articles. Understanding the relevant articles in the National Electrical Code is crucial. Article 300 covers general wiring methods and includes requirements for protection against physical damage, corrosive conditions, and wet locations. Article 314 addresses outlet, device, pole, and junction boxes, conduit bodies, fittings, and handhole enclosures. It specifies requirements for enclosures in damp and wet locations. Article 344 covers rigid metal conduit, outlining its permitted uses, installation requirements, and grounding procedures. Article 352 pertains to rigid polyvinyl chloride conduit, detailing its approved applications, installation practices, and support requirements. Secondly, detailed look at fitting types. Fittings designed for wet locations are engineered to prevent water from entering the conduit system. Compression fittings create a watertight seal by compressing a sealing ring or gasket against the conduit. Threaded fittings use tapered threads to create a tight seal when screwed together. O-ring fittings utilize O-rings to create a watertight seal between the fitting and the conduit. Sealing lock nuts are used to seal the connection between a conduit and a box or enclosure. Thirdly, installation best practices. Proper installation is paramount to ensuring the long-term performance and safety of the conduit system. Conduit should be supported at intervals specified in the NEC to prevent sagging and maintain its integrity. All joints and connections should be made in accordance with the manufacturer's instructions and using the appropriate tools. Underground conduit should be buried at the depth specified in the NEC to protect it from physical damage. Fourthly, grounding and bonding considerations. When using metal conduit, proper grounding and bonding are essential to minimize the risk of electrical shock. The conduit system should be bonded to the building's grounding electrode system to provide a low impedance path for fault currents. Bonding jumpers should be used to ensure electrical continuity between all metal components of the conduit system. Fifthly, expansion and contraction management. Outdoor conduit systems are subject to temperature fluctuations that can cause expansion and contraction. Expansion fittings should be installed at intervals recommended by the manufacturer to accommodate this movement. Expansion fittings allow the conduit to expand and contract without putting stress on the system or causing damage. Sixthly, drainage solutions. In certain applications, it may be necessary to provide drainage for the conduit system to prevent water accumulation. Drain fittings can be installed at low points in the conduit run to allow water to escape. Drain fittings should be designed to prevent debris from entering the conduit system. Seventhly, inspection and maintenance protocols. Regular inspection and maintenance can help identify and address potential problems before they escalate. Check for signs of corrosion, water damage, or loose connections. Repair any damage promptly to maintain the integrity of the conduit system. Eighthly, documentation practices. Maintaining accurate records of the conduit system can be valuable for future maintenance and troubleshooting. Document the type of conduit and fittings used, the installation methods, and any modifications made over time. Keep this documentation in a safe and accessible location. Ninthly, importance of professional expertise. Consulting with a qualified electrician or electrical engineer is always recommended, especially for complex installations or when working in unfamiliar environments. These professionals can provide valuable guidance on selecting the appropriate materials and installation methods to ensure a safe and code-compliant installation. By following these guidelines and best practices, you can ensure that your conduit system provides reliable and safe electrical service in wet locations. Remember to prioritize safety and to consult with qualified professionals when necessary. The selection and installation of conduit in wet locations also involves understanding the specific types of enclosures and boxes that are suitable for such environments. These enclosures play a crucial role in protecting electrical components from moisture and ensuring the safety of the installation. Firstly, understanding enclosure types. Enclosures for wet locations are typically classified based on their NEMA, National Electrical Manufacturers Association rating. NEMA ratings indicate the level of protection that an enclosure provides against environmental factors such as water, dust, and ice. NEMA Type 4 enclosures are designed for indoor or outdoor use to provide protection against splashing water, rain, and hose-directed water. NEMA Type 4X enclosures offer the same protection as Type 4 enclosures, but they are also corrosion resistant. This makes them suitable for use in harsh environments where exposure to chemicals or salt is a concern. NEMA Type 6 enclosures are designed for indoor or outdoor use to provide protection against temporary submersion in water. Secondly, selecting the right enclosure. The selection of the appropriate enclosure depends on the specific environmental conditions and the type of equipment being housed. For example, in a car wash, a NEMA Type 4X enclosure would be recommended to protect electrical components from water and chemicals. In an outdoor application where the enclosure is exposed to rain, a NEMA Type 4 enclosure would be sufficient. Thirdly, enclosure materials. Enclosures for wet locations are typically made from materials that are resistant to corrosion and water damage. Stainless steel enclosures offer excellent corrosion resistance and are suitable for use in harsh environments. Fiberglass enclosures are lightweight and corrosion resistant, making them a good choice for outdoor applications. Polycarbonate enclosures are impact resistant and can withstand a wide range of temperatures. Fourthly, installation practices. Proper installation of enclosures is essential for maintaining their integrity and ensuring that they provide adequate protection. Enclosures should be mounted securely to a stable surface. All openings in the enclosure, such as conduit entrances, should be properly sealed with watertight fittings. The enclosure cover should be properly gasketed and tightened to prevent water from entering. Fifthly, grounding and bonding. When using metal enclosures, proper grounding and bonding are essential for preventing electrical shock hazards. The enclosure should be bonded to the building's grounding electrode system. All metal components within the enclosure should be bonded together to ensure electrical continuity. Sixthly, maintenance and inspection. Regular maintenance and inspection of enclosures can help identify and address potential problems before they become serious. Check for signs of corrosion, water damage, or loose connections. Repair any damage promptly to maintain the integrity of the enclosure. Seventhly, code compliance. The installation of enclosures in wet locations must comply with the requirements of the National Electrical Code. The NEC specifies requirements for the type of enclosure, the installation methods, and the grounding and bonding procedures. Eighthly, documentation. Maintaining accurate records of the enclosures used in the electrical system can be valuable for future maintenance and troubleshooting. Document the type of enclosure, the NEMA rating, the materials used, and the installation methods. Ninthly, professional consultation. When in doubt, it's always best to consult with a qualified electrician or electrical engineer. These professionals can provide valuable guidance on selecting and installing enclosures that meet the specific requirements of the application and comply with all applicable codes and standards. By carefully considering these factors, it's possible to select and install enclosures that will provide reliable protection for electrical components in wet locations. Remember to always prioritize safety and to consult with qualified professionals when necessary. Further expanding on the practical aspects, it's beneficial to consider real-world examples and common challenges encountered when dealing with EMT and other conduit systems in wet locations. Firstly, real-world scenarios. Consider a commercial car wash facility. The entire environment is consistently exposed to water and cleaning chemicals. In this scenario, using EMT with standard fittings would be entirely inappropriate due to the high risk of corrosion and water ingress. Instead, a system employing PVC conduit with NEMA 4X rated enclosures and fittings would be a much better choice. The PVC offers excellent resistance to the corrosive chemicals, and the NEMA4X enclosures ensure that all electrical connections and components are protected from water damage. Another example is an outdoor marina setting. The electrical systems powering boat lifts and dock lighting are constantly exposed to saltwater. Here, aluminum conduit or stainless steel conduit with appropriate watertight fittings would be preferred. Aluminum is naturally corrosion resistant, and stainless steel provides even greater protection in harsh marine environments. Secondly, common challenges and solutions. One common challenge is dealing with existing EMT installations that are now exposed to wet conditions due to changes in the environment or building usage. A solution could involve replacing the existing EMT with a more suitable conduit system, such as PVC or liquid-type flexible metal conduit LFMC, ensuring that all connections are properly sealed and that the new system meets current code requirements. Another challenge is ensuring proper drainage and conduit runs that are prone to water accumulation. Installing drain fittings at low points in the conduit run can help prevent water from pooling and causing corrosion or electrical issues. Regularly inspecting and maintaining these drain fittings is also important to ensure they remain functional. Thirdly, the importance of proper training. Electrical work in wet locations requires specialized knowledge and skills. It's crucial that electricians and other personnel involved in these installations receive proper training on the selection, installation, and maintenance of conduit systems and enclosures for wet environments. This training should cover relevant codes and standards, as well as best practices for ensuring safety and reliability. Fourthly, documentation and record keeping. Maintaining accurate and up-to-date documentation of all electrical work is essential. This documentation should include details about the type of conduit and fittings used, the installation methods, any modifications made, and any inspections or maintenance performed. This information can be invaluable for future troubleshooting and maintenance. Fifthly, the role of inspections. Regular inspections by qualified electrical inspectors are critical for ensuring that electrical installations in wet locations meet code requirements and are safe. Inspectors can identify potential problems such as improper grounding, damaged conduit, or inadequate sealing, and can require corrective action to be taken. Sixthly, understanding listing and labeling. Always look for the UL listing or other recognized testing laboratory labels on conduit, fittings, and enclosures. These labels indicate that the products have been tested and certified to meet specific safety standards. Using listed and labeled products is essential for ensuring that the electrical installation is code compliant and safe. Seventhly, addressing corrosion concerns. Corrosion is a major concern in wet locations, especially those exposed to saltwater or chemicals. Using corrosion-resistant materials such as PVC, aluminum, or stainless steel is essential for preventing corrosion and ensuring the long-term reliability of the electrical system. Applying protective coatings to metal conduit and fittings can also help to prevent corrosion. Eighthly, considering future needs. When designing and installing electrical systems in wet locations, it's important to consider future needs and potential changes in the environment or building usage. Choosing a conduit system that is adaptable and can accommodate future expansion or modifications can save time and money in the long run. Lastly, staying up to date with codes and standards. Electrical codes and standards are constantly evolving. It's important for electricians and other personnel involved in electrical work to stay up to date with the latest changes and to ensure that their installations comply with current requirements. This can involve attending training courses, reading industry publications, and consulting with qualified electrical inspectors. By taking these practical considerations into account, you can help ensure that electrical installations in wet locations are safe, reliable, and code compliant. Remember to always prioritize safety and to consult with qualified professionals when necessary. Here are a few points concerning the electrical systems in wet locations. Firstly, corrosion prevention strategies. Implementing robust corrosion prevention strategies is essential to extend the lifespan and reliability of electrical systems in wet locations. This involves selecting appropriate materials, applying protective coatings, and implementing regular inspection and maintenance programs. Consider using cathodic protection systems in certain situations to further mitigate corrosion. Secondly, advanced sealing techniques. Employ advanced sealing techniques to ensure watertight connections and prevent moisture ingress. This includes using specialized sealants, O-rings, and gaskets that are designed for use in wet environments. Properly torquing all connections is also important to ensure a tight seal. Thirdly, monitoring and detection systems. Consider implementing monitoring and detection systems to identify potential problems early on. This could involve using moisture sensors, corrosion probes, or thermal imaging cameras to detect leaks, corrosion, or overheating. Fourthly, energy efficiency considerations. When designing electrical systems for wet locations, consider energy efficiency measures to reduce energy consumption and lower operating costs. This could involve using energy-efficient lighting, motors, and other equipment. Optimizing the layout of the electrical system to minimize voltage drop and reduce losses can also improve energy efficiency. Fifthly, renewable energy integration. Explore the possibility of integrating renewable energy sources, such as solar or wind power, into electrical systems in wet locations. This can help to reduce reliance on fossil fuels and lower carbon emissions. However, it's important to ensure that all renewable energy components are properly protected from moisture and corrosion. Sixthly, smart grid technologies. Consider incorporating smart grid technologies into electrical systems in wet locations to improve reliability, efficiency, and control. This could involve using smart meters, automated switches, and remote monitoring systems. Seventhly, surge protection. Surge protection devices, SPDs, are critical for protecting electrical equipment from voltage spikes and surges, especially in wet locations where the risk of lightning strikes is higher. SPD should be installed at the service entrance and at any sensitive equipment. Eighthly, safety protocols. Strictly adhere to safety protocols when working on electrical systems in wet locations. This includes wearing appropriate personal protective equipment, PPE, such as rubber gloves and insulated boots. Always energize circuits before working on them and use lockout-tagout procedures to prevent accidental re-energization. Ninthly, emergency preparedness. Develop emergency preparedness plans to address potential electrical hazards in wet locations. This could involve training personnel on how to respond to electrical shocks, fires, or floods. Having readily available emergency equipment, such as fire extinguishers and first aid kits, is also important. Lastly, continuous improvement. Continuously seek ways to improve the design, installation, and maintenance of electrical systems in wet locations. This could involve conducting research, attending industry conferences, and collaborating with other professionals. By staying informed and adopting best practices, you can help to ensure that electrical systems in wet locations are safe, reliable, and efficient. The NEC and UL guidelines are subject to interpretation, and that local jurisdictions may have their own specific requirements. It is important to consult with local electrical inspectors or authorities having jurisdiction, OJ, to ensure compliance with all applicable regulations.